Okay, it just finished, and you can see, sure enough, that the GPU RAM zoomed up there and is at 8.5 gigabytes. One thing that was important that I didn't mention is this parameter here, number of inference steps. So this is a bit hand wavy, but you may know the way these diffusion models work is that they started with a picture which had a description of it, like a prompt. And then they gradually dissolve that away into white noise through various steps. And the way a diffusion model is trained is then doing that in reverse, starting with the fuzz with a prompt and then trying to iterate to get towards the full picture. And the number of inference steps is how many of these kinds of steps of changing something that is noisy into something that's a real picture based on a prompt. So this model, this very, very small SDXL turbo model, achieved this, which is sort of fun. Is this you? Do you look like this? This is the class of data scientists in a vibrant pop art style, and it's colorful and poppy. And, of course, it's not like the OpenAI ones that we saw with the amazing pictures of London and Paris and New York. But it's free. It's a free model, and you have all the code. This Hugging Face code we're using here, but this pipelines, which is part of one of these Hugging Face libraries, you've got all the Python code running on this box, generating this picture, and that's kind of cool. It certainly feels very tangible. Okay, the next thing we're going to do is reset the kernel to bring everything back down again and run another model. You can reset the kernel by going to runtime and restart session. I put it down here as some code that you can run yourself just by doing this. It will also do it. It's going to prompt me and tell me that the kernel is gone. There we go. Your session crashed. It says automatically restarting, and back it comes with everything back down to 0 again. Same as runtime restart. Okay, we're now going to kick off another model, which is also another one from Stability, from Stable Diffusion. It's the Stable Diffusion XL base, which is a bigger model, and we'll let this thing run. This time we're going to be doing 30 inference steps. It's a bigger image it's going to produce. It's not significantly different quality to this one, in case you're expecting big things. We're running on a tiny box when it comes to image generation. They consume a lot of power, but it's still cool to be running ourselves on this free kit. And I hope you're doing it too. And that there's definitely something very tangible about doing it. I will see you for the outcome. And here we're just watching the end. It all loaded. You can see the 30 iterations that it's doing. This one was on 30 inference steps. They're running pretty fast. And at the end of it, up pops the image. I hope there it is. So, it's a bigger image. There's more going on. It's still a bit messy, but I think that's maybe part of the pop art style, and something a bit surreal and strange happening around here that looks like a bit of an AI artifact. But nonetheless, this is something kind of cool to be built, coming just again on our free box. And then you can see as well, look at the GPU went all the way up to 12.7 there. So we're going to restart the kernel again and go back to blank. And now I think we're now probably getting to the area where to run this next one, it may not run on a typical box. It may be time for us to run on a powerful box, which I have, which you probably don't have, which I want to do just to show you what it's like to run on a more powerful box. I will just try it first on a T4 to see whether it runs. So this, while it's running, let me just tell you, is again, it's the same XL base 10, which is a larger model that is able to build this bigger look. But we're also bringing in a second model to act as the refiner. And you can see that we split it 80-20, and the refiner gets to work on making it just that little bit better. So that is running now, and we'll see whether it runs on this T4 box. I think it probably won't. It'll probably run out of memory, which will be a nice time to show you what it looks like when you run out of memory on a T4. And at that point, I will switch to an A100, a powerful box instead. But we'll see what happens. I'll see you in a second. Okay, so this two-stage diffusion did complete successfully on the free T4 box. Here's the result. And it's definitely a step better, there's no doubt. It's still got artifacts and some weirdness, but it's kind of cool as well. And again, when it comes to a free open source model on free hardware, it's kind of cool to be doing this. So hopefully you've had this experience too. You've also seen some interesting pictures. You may be able to prompt it better and get something crazier or more fun or whatever. But this is our pop art style data scientists aspiring to be expert AI engineers. That would be you. All right. So with this, we are now going to change and move on. Oh no, just before we move on to an A100, I have one more thing to show you on your own T4. Let me show you something else. So this time I'm going to do it the other way. Runtime menu, restart session, restart. Okay. Again, look at how close we were to the top of the memory there. It only just barely squeezed onto our T4. But now we've done a restart kernel. Everything should be bam, all the way back down to 0 again. And now I'm going to run this next cell. So we are now using transformers, the main library from Hugging Face, not diffusers, not the image generation, but we're back to normal transformers. But we're not using it for text generation. We're going to use it to use a free text to speech. You remember the TTS model we looked at last time? We were using a paid model last time. This time it's a free one. It's from Microsoft. It's the Microsoft Speech 5 TTS. We're loading it in and we're going to say hi to an artificial intelligence engineer on the way to mastery. And of course, it first needs to do a fair bit of loading in, and this would be a one-time thing. This wouldn't, if you had this model loaded in memory, you wouldn't need to do all of this downloading from Hugging Face that we're doing now. You would only need to do the part that actually runs the model, which is hopefully relatively fast. But we'll just let this finish. There it goes, coming across. Okay, it's got to download some more of the model. It's also going so fast. I know as soon as I stop, it's going to finish. But I will see you in 1 second. And actually, for that to work, I had to do a little pip install right here. So I've added that in there. You'll need to run that first for this to work properly. But when you do then run it, you get this. And then when I press play, we'll see what we get.
Hi to an artificial intelligence engineer on the way to mastery.
There we go. So we just generated some lovely audio on our free T4 box. That was successful. Congratulations. You've used Google Colab to connect to a free GPU box in the cloud. And you've used it to generate a number of images, and you've used it to generate audio as well, using diffusers and using a transformer. One more thing to do. Okay, so I'm now going to connect to a powerful A100 box. So I'm going to leave you as I go over to this. If you wish, you can come along with me. Let me do this now. Change runtime type. A100, disconnect and delete runtime. Yes, and save. And are you still there? I'm not a robot. There we go. It connects. I move so fast, it thinks that I'm automated. It's happened. It's connected to an A100. You can see because I have 40 gigabyte RAM on my GPU, which is enormous. This is going to cost 5 compute units per hour. And $10 costs about $10 gets you 100 compute units. So $1 gets you 10 compute units. So basically an hour is about 50 cents. That's about how much you pay for an hour use of this. Come on, it's not that bad. I said I thought it was a couple of dollars. It's not too bad. And just to prove it, let's just print the name of the GPU, the same code as before. You can see now that it is an NVIDIA A100 GPU, and it should have, there we go, 40 gigabytes of RAM. And now I'm going to run another image generator, and I'm using the famous Black Forest Labs FLUX 1, which is a model that image people love to talk about. It comes in 3 different sizes, Schnell and Dev and Pro, and we're going for Schnell, which is the smallest, cheapest one, because we don't have that much time to leave this running. A class of data scientists learning AI engineering in a vibrant, high-energy pop art style, and with just 4 inference steps. So leaving this running, I just got some code to time it as well. Again, we're using this thing called a pipeline, which is the easy way to use Hugging Face code. We're going to talk in the next couple of days about the easy way and the hard way. And the easy way are these pipelines that come kind of pre-baked. So the pipeline is running. It's starting by downloading tons of stuff. In it all comes, and then the A100 will be at work. This is a super powerful, a beefy box that we're remotely connecting to right here. And I will go away and wait for a while for this to complete, and I will see you when it's done. Okay, that just completed. So this was the famous Black Forest Labs, the FLUX 1 Schnell model. The prompt, you remember, was a class of data scientists learning AI engineering in a vibrant, high-energy pop art style. Look at that. It's used 36.8 gigabytes of the 40 gigabytes available on the A100. So it certainly, we made the best use of our hardware. Let's see what Schnell was able to come up with. Here is the result. And I got to tell you, I think this is pretty cool. That definitely looks like a vibrant pop art image of a bunch of aspiring AI engineers. I'd say that is great. And this time it wasn't running on free hardware, but the model was free open source model running. And I guess, well, actually, you may be wondering how much it costs to do that. So I did a little calculation here. I got the total number of seconds, calculated the units per hour, and then turn that into an estimated cost based on the fact that it costs about $10 to have 100 units. And so it ends up that actually, in the end, it took 240 seconds. And my estimate, if I've done the maths right here, is that cost 4 cents for us to create that image in terms of our time on Google Colab, which is actually quite similar to the cost, if you remember, that we paid for OpenAI, which just goes to show you that all these things end up being pretty similar in the end. So there we go. There you have it. That is the result of us running image generation on a beefy A100 GPU that we have got access to by running in the cloud on Google Colab. And this Colab, of course, is shared with you, so you can come through and run this and have all of the T4 experience yourself. And then should you wish to splash out a little tiny bit more, then you can get this A100 experience too. And of course, where they get you is that, sure, it only costs 4 cents to actually generate that image, but I'm still running that A100. You have to remember to go to runtime and say disconnect and delete runtime to stop paying for it. At any time, you can come here and go to manage sessions to see all of the sessions you've got running and make sure that you stop like this, terminate, off it goes when you're finished with a session. And with that wraps up our exploration of Google Colab for today. Okay, and we got a lot done. That concludes week 3, day 1. It wasn't that much like pulling teeth in a dentist's office. There was some cool stuff there. And in the meantime, you've been exposed to navigating the Hugging Face platform. You've had your first little look at some of the Hugging Face libraries, although we haven't gone into them yet, but you have run code on Google Colab. And in addition to that, you can, of course, confidently code with frontier models and build a multimodal AI assistant with tools. Congratulations. Next time, we're going to talk about the 2 different flavors of Hugging Face API. We're going to dig into pipelines and use them for a bunch of AI tasks like generating text, generating images and audio. So much to do. See you then.